Today we're doing section 2.3. We're going to be doing polynomial functions and graphs, and this is our first day in the notes. So first thing we're going to discuss is n behavior. So this is the general that a is your coefficient, x and n is your highest power of any given polynomial. So if n is odd, the general n behavior goes that it travels from downward position to an upward position. Obviously we don't care about anything that's in between. We're just talking about the n behavior. And this is what it looks like if a is positive. So we'll say if a is greater than 0. Our n behavior flip-flops if a is less than 0, but notice the n behavior is still opposite directions. It goes up, then down. If your power is even, so if it's raised to the second, fourth, sixth power, and so on, it either goes up, up, or down, down. And what determines that is, again, the coefficient. So if it's positive, it's up, up. If it's negative, it's down, down. So we're going to go ahead and try a problem. So the idea is that we're going to determine the n behavior without looking at the graph, just using the rules. So here, we would have to kind of multiply this all out to figure out what our highest power is. So I know I definitely have this x cubed. When I would square this quantity, I would definitely get an x squared from it. And here, from that last term, I would get an x. And I know I add those exponents together. So without having to multiply the whole thing out, I know I'm going to be at x to the 6th power. So and then we have to figure out our coefficient. So this is a -4. This would be a 1 and a 1. So I would have a -4x squared. So I know my parabola, because it's my coefficient's negative and my exponent is even, it's going to be down, down. So to kind of tie this into what we did last year, we said, okay, as x approaches infinity, f of x, which means y, goes to -infinity, and as x goes to -infinity, my y values also go to -infinity because the parabola would go, or this function would be down, down. So here is another problem where the textbook is giving you this picture. So this is the graph that's supplied to you, and they want to know if this is the whole graph or if it's zoomed in. So I need to, again, look at the first term. I have a negative a value, and my power is even. So this is negative, my power is even, so I know the n behavior is supposed to be down, down. So based on this picture, this is not the complete graph. And again, we know this because this graph is going from down to up, and it's supposed to go down, down. So that's how we know this is not the complete graph and that this portion of the graph is just zoomed in. So the next thing we're going to discuss is finding the zeros, and zeros is another way of saying the x-intercepts. And we know if we're trying to find the x-intercepts that we set y equal to 0. So obviously we can't use quadratic formula here because I'm in the 3rd power, not the 2nd power. So some options here are to try and factor. So since there's 4 terms, we can try factoring by grouping. For those of you who do the box method, you have all 4 terms, so you just go right into the box. Those of you who group, you're going to group your first 2 and your second 2, and you start by taking out what you can. So my GCF here is x squared, and I'm left with x plus 3. In the second quantity, I'm left GCF's -1, and I'm left with an x plus 3. So this factors down to be x squared minus 1 and an x plus 3. Now let's say you tried this factoring by grouping and these 2 quantities don't match up. That means it's not factorable. So that's how you would kind of know. For my box people, you wouldn't be able to find any combination on the outside. Because it said find all the zeros, we need to set both quantities equal to 0. So when I set x squared minus 1 equal to 0, I'd add 1 over. And then I'd take the square root, and I get x equals plus or minus 1. And from the other quantity, I would get -3. So there are my 3 answers. And again, we know we get 3 answers because it's to the 3rd power. So this is, again, an example of factoring by grouping, and you do that when you have 4 terms. The next one is a different way to go about it. So notice I don't have 4 terms, so I can't just start grouping them or putting in the box, but I can look at this and say that I determined that I have a GCF. So my GCF here is an x squared. So I'm going to take an x squared out of every term. And I'm actually going to take a negative x squared because I don't like factoring with a leading coefficient that's negative. So if I take a negative x squared out, I'm going to be left with a positive x squared minus 4x plus 4 equals 0. And now I can factor this second quantity, so I figure out multiply to be 4, now it's to be negative 4. So that's a negative 2 and a negative 2. So my box people, there's your combination. My groupers, you're going to split it up with a minus 2x plus 4. And then you group the first two and group the second two. I can take out an x. And in the second quantity, I can take out a negative 2. So this factors down to be x minus 2 and an x minus 2. And again, this negative x squared that we pulled out for initially is just following us through. So, and again, the ultimate goal is to solve and find the zeros. So from this first value out front, when I set that equal to 0, I get the answer of 0. And then I get the answer of 2 from both of those quantities. So this is what we call a double root. 0 and 2 are both called double roots because I get the same answer twice. So that's all for today. We're going to pick up with this tomorrow.